Hi there. Thanks for joining me. My name is Mihir. I'm 14 years old. I live in Navi Mumbai, India. My topic is radiation. I chose this topic because many people have some misconceptions about radiation. Here's what internet thinks about radiation is everywhere. So, let's discover where we will encounter radiation in our everyday lives. Do you want to see radiation? Come with me. There you go. That's radiation. Right, that's radiation. Yes, light is a form of radiation. It is an electromagnetic wave. Guess what? Sound is a type of radiation. Radiation is everywhere. People think of radiation as something dangerous, something which they should stay far from. They forget the fact that light, sound, and even heat is a form of radiation. Radiation, without radiation, nor microwaves will work, nor your radio, nor your TV, not even your internet. So, what is radiation? What is the definition of radiation? Well, here's the definition of radiation according to the Wikipedia. Radiation is the transmission of energy in the form of waves or particles through space or through a material medium. Radiation can be divided into two parts, ionizing radiation and non-ionizing radiation. So, we'll first start with ionizing radiation. To understand ionizing radiation, first we have to understand the structure of atoms and ionizing. Ionizing radiation is a radiation with enough energy to free electrons from the atom. High exposures to ionizing radiation can be extremely dangerous. It can kill cells, change your DNA, or even destroy your DNA completely. But we all are exposed to small doses of ionizing radiation, mainly from nature. There are mainly five types of ionizing radiation which are very common. First is UV light with high frequency. UV light with high frequency is usually blocked by ozone layer. X-rays. X-rays is the same light which is used in X-ray machines. Third, gamma rays. We'll discuss more about gamma rays later. Fourth, alpha particle radiation. And fifth, beta particle radiation. So, this is an atom. Now, sometimes the nucleus of the atom is extremely unstable. Now, you might not have heard unstable nucleus in chemistry, but this is nuclear chemistry. Here, not the nucleus can be unstable, so can be the atom. Now, if the nucleus is unstable, the atom has three options. Option number one, it can emit an alpha particle. The alpha particle. The alpha particle consists of two protons and two neutrons. Sometimes the shoot the two protons and two neutrons out of the nucleus in order to become stable. Now, the alpha particle has two protons. That means it is an helium atom, as its atomic number is 2. An alpha particle is extremely heavy and is the most ionizing, of which we are going to speak. The alpha particle can travel very long distance. It can even be stopped using a thin sheet of paper. It mostly can't penetrate through our skin. But if someone inhales an alpha particle, it can be hazardous. Second option, the beta particle. If an atom is extremely unstable due to a more number of protons or more number of neutrons, then it has two options. If it has more number of protons, then a proton can turn into a neutron, or if it has more number of neutrons, then a neutron can turn into a proton and release a beta particle. A neutron can turn into a proton plus a beta particle, and a proton can turn into a neutron plus a beta particle. The beta particle. The beta particle is an energized electron. It's actually an electron with a high kinetic energy. It is a moderately ionizing, less ionizing than alpha and more ionizing than gamma. It can travel moderate distances. It can be stopped using a or thin sheet of aluminium. Third, the gamma particle. If the nucleus is extremely excited, yes, that's the technical term, then it can release a gamma particle to stay stable. So, let's look at the properties of gamma ray. The gamma ray. The gamma ray is an electromagnetic wave with a wavelength of 10 to the negative 12 to 10 to the negative 16 meters. Now that is a very small number. It is weightless, obviously, and it's the least ionizing of the three. It can pass through your body and can be blocked by a thin sheet of metal. It is extremely dangerous as well as useful. It is used to treat cancers and tumors. This is a graphical representation of an electromagnetic wave. Now, the waves which are red in color and are going up and down are the electric waves, and the waves which are going side by side and are blue in color are the magnetic waves. The distance between the two up red waves which I am marking by my cursor is called the wavelength. Now, the wavelength is an extremely important factor for the physical properties of the electromagnetic wave. So this is the electromagnetic spectrum. Now these are the wavelengths and these are the name of the electromagnetic waves having these wavelengths. These are all different types of lights which we cannot see. This is the visible light spectrum. This tiny fraction of this huge electromagnetic spectrum is what we can see. That means that we cannot see most of the universe. These are gamma rays. These are X-rays, and this is UV light. Now, the lower frequencies of UV light, X-rays and gamma rays are all types of ionizing radiation, as discussed earlier. Now, higher wavelengths of UV, the visible spectrum or the visible light, the infrared, microwaves, radio waves, long radio waves are all types of non-ionizing radiation. That means they do not have enough energy to free electrons from their atom. So let's discuss where we encounter these non-ionizing radiations. Well, this is the visible spectrum. Obviously, we cannot see without this. So this is one of the most important parts of the spectrum. The infrared. You might have heard about the infrared camera. It is often used to detect the objects, the amount of heat an object releases. Snakes can see infrared. Microwaves. Microwaves, as the name suggests, are used in microwaves. The radio waves. Radio waves are used by radio to capture signals and therefore play your favorite music. Long radio waves. Some countries, these waves are used as radio waves. Sound and earthquakes or seismic waves are also a form of non-ionizing radiation. Just think about it. Think about some other things which can be called as radiation, but we don't even have the blindest idea that they are actually a form of radiation. Answer in the comments below.